Okay, so today we're going to be looking at rates of change in polar functions. So on this one, it's important for us to be able to sort of compare how the function is looking in a Cartesian graph to how it's going to look in the polar graph. In particular, we're looking to see when the polar graph is increasing or decreasing in distance from the origin. So this is all about looking at a point on the polar graph and comparing how far it is away from the origin and whether the distance is increasing or decreasing as we move along the graph. This will allow us to identify where maximum and minimum points occur. So the rate of change in a polar coordinate, the essential information to learn on this one is that the distance between a point on the graph, so a point on the graph might be a point like this particular point. We want to know how big is this distance here? Is it increasing as we move around in the angles? So as we move to here, it would have increased. It's now a bit longer. And how do we interpret that? So we do that by looking at the graph in the Cartesian plane. If the graph in the Cartesian plane is positive and increasing, or if it is negative and decreasing, then the distance between a point on the polar graph and the origin is going to be increasing. Now, if the Cartesian graph is positive and decreasing, or the Cartesian graph is negative and increasing, it's getting closer to the origin. So the distance between the point on the polar graph and the origin is going to be decreasing. Let's have a look at that. So if we look at the graph given here, we need to determine the intervals in which it is going to be the distance. So this is the Cartesian graph. Considering the polar graph for this one, the distance will be increasing from the point on the graph and the origin when this one is positive and increasing, which is here and here. It's also going to be increasing, but in a negative direction when it is negative and decreasing. So here. So positive and increasing, these first two, that's going to give us an interval from 0 to pi over 2, and it's going to be from 11 pi over 6 to 2 pi. This means that this is going to be increasing. It's also going to be increasing when it's negative and decreasing. So it's negative and decreasing in this interval from 7 pi over 6 to 3 pi over 2. So when the Cartesian graph is negative and decreasing, that means the point between the origin and a point on the polar graph is going to be increasing. Now, when it's positive and decreasing, like here, that is an interval from pi over 2 to 7 pi over 6. This means that the polar graph is going to be decreasing. What that means is a point on the graph, the distance between a point on the graph and the origin is going to be decreasing as the angles increase. It's also going to be decreasing and getting closer to the origin here in this section. This is where the graph is negative and increasing. And this is going to be from 3 pi over 2 to 11 pi over 6. So here it will be decreasing. So consider the graph of the polar function r equals f of theta, where f of theta is equal to 2 minus 4 cosine theta in the polar coordinate system from 0 to 2 pi. Which of the following statements is true? So in order to do this, we want to sketch the Cartesian graph in that interval. So sketching our Cartesian graph is going to look like this. We can see that the principal axis is going to be here at y equals 2. There's a reflection in this graph. So the graph is going to be starting off down here, going up and then coming down again. The minimum point on the graph here is going to be at 0, -2. This point here is also going to be at 2 pi, -2. And this point here is going to be at 2 + 4, so 6. And that is going to be at pi, 6. The interesting points for us are these points here. So we need to find where the coordinates of these points. The y coordinate's obviously going to be 0. That's where it changes from positive to negative. And it'll give a change in how the polar graph is going to look. So we have to solve that. That gives us 2 - 4 cosine theta is equal to 0, which gives us cosine theta is equal to 1/2. And solving that is going to give us, so let me just do a little sketch of the unit circle, help me solve that one. I'm interested in a point that's going to be here at 1/2. The cosine, this is where x equals 1/2. So the two values are going to be here and here. The first one is going to be that theta is equal to pi/3 from our exact value table. And then we have to reflect that down at minus pi. So 2 pi minus pi/3 is going to give us theta is going to occur at 5 pi/3. So this coordinate here is pi/3, 0. And this coordinate here is 5 pi/3, 0. So, looking through our first statement here, the distance is increasing from pi. So where is that? So our polar graph is going to be increasing here and increasing in distance here. It's going to be decreasing in these intervals. This is where it's increasing, and these are where it's decreasing. So from pi to 5 pi/3, that's this pink interval here, the distance is increasing. No, it's not. It's decreasing. So it's wrong. The distance is increasing from 5 pi/3 to 2 pi, so we're down here now, and that is true. It is increasing here, and it is negative, but this distance is not increasing on the interval. The Cartesian graph here is decreasing. Although the values are getting bigger, they're getting bigger in a negative direction, which we consider to be decreasing. So it's this word here that's not correct. So in C, we're looking at this one again here, from pi to 5 pi/3, and the distance is decreasing. Yes, that's correct. It is positive. It is decreasing. So C is the correct answer. Let's have a look at the last one, D. That is the same interval, that's 5 pi/3, it's down here. It's not decreasing, it's increasing. It's increasing in a negative direction. So C is the correct answer. Okay, so we have a similar type question here. We've got the graph of f of x equals 3 sine 2x on the interval from 0 to 3 pi/2, shown in the Cartesian coordinate system, or the rectangular coordinate system. If the polar function, r equals f of theta, is graphed on the polar coordinate system for the same interval, on which of the following intervals is the distance between the point on the polar coordinates and the origin decreasing? So it is going to be increasing here, increasing here, increasing here. It's going to be decreasing on these intervals, getting closer to the origin when it's decreasing, and we want it to be decreasing. So from 0 to pi over 4, no, that's that first one, that is increasing. From pi over 2 to 3 pi over 4, no, that is increasing. From 3 pi over 4 to pi, yep, that one is correct. From pi to 5 pi over, no, that one is not correct. So our correct answer here is C. Okay, so relative extrema. Now, relative extrema means we've got a maximum point or a minimum point on the graph. So relative extrema are going to occur. So maximum and minimum, these are going to occur when it changes. The rate of change changes from increasing to decreasing or from decreasing to increasing. What is it talking about? Let me have a little look here. So this is a polar graph. It has various relative extrema. It's going to have a maximum point here at this point. It's going to have a point maximum here. It's going to have a maximum here. It's going to have a maximum here. It's going to have several minimum points here when the distance between the curve and the origin is 0. So those are the maximum and minimum. We have oops, don't have any more. Let's have a look at the question. So if we consider the graph 1 minus 2 sine 2 theta in the polar coordinate system from 0 to pi, which of the following statements is true? So we are only looking at from 0 to pi, so we need to solve and sketch for this graph. So we want to sketch y equals 1 minus 2 sine 2x. We're going to have our principal axis here, at y equals 1. It's a sine function which has been, we got an increased, the period is only going to be pi. We can see that p is equal to 2 pi over 2, so the period is pi. It's got a reflection, so it's going to start off by going down and then up. So the graph is going to look like this. This point here is pi. This point here, let me just do it like this. This point here is pi over 2. And this point here is at 0. This point here is going to be pi over 4. And this point here is going to be 3 pi over 4. We need to find these points. So we need to solve 1 minus 2 sine 2x equals 0, which gives sine 2x is equal to a half. So theta is going to be equal to pi over 6 plus n2 pi, or it's going to be equal to pi minus pi over 6, 5 pi over 6 plus n2 pi. And this is I'm solving in x. This is 2x. So x is going to be pi over 12 plus n pi, 5 pi over 12 plus n pi. We only want the first two solutions to this. So x is going to be pi over 12 or 5 pi over 12. This is pi over 12. This is 5 pi over 12. So let's read through each statement. So the minimums for this one are going to be occurring here and here because the distance between the point on the curve on the polar graph and the origin is going to be 0. So the graph will have a minimum on the interval for pi over 3 to 2 pi over 3. Where's pi over 3? So pi over 3, let me just switch pen. Pi over 3 is going to be around about there. And 2 pi over 3, so 2 pi over 3 is going to be here. This is pi over 3. This is 2 pi over 3. So in this interval, we change from a decreasing curve to an increasing curve. This will give us a minimum. So this is correct. But the reason, because it changes from negative to positive. Okay, so this is true. It does change from negative, but this isn't the reason that it has a minimum. It will have a minimum because it changes from increasing to decreasing or decreasing to increasing. So in this statement here and in this statement here, it gives the wrong reason. It says that the reason is that it moves from positive to negative or negative to positive. These are not the reasons. We need reasons that look like this, increasing to decreasing. So we found that there is a minimum here at this one, and it's for this reason, so this is going to be the correct answer. Let me just check B. So B is from 2 pi over 3. So from 2 pi over 3 to pi. In that case, the graph is increasing, and then the distance is decreasing. So the reason there is wrong. It says it's decreasing to increasing. So this reason is wrong. And also, this is going to give us a maximum. I'm a little bit all over the place on this. Let me just clarify. I got the interval. So the interval that we're looking at is 2 pi over 3 to pi. So from 2 pi over 3 to pi, it's this one. This will be a maximum because the distance is at its greatest. Here at this point, the distance is at its greatest. But the reason it is a maximum is because the curve is got the distance on the polar curve between the point on the polar curve and the origin is first increasing and then decreasing. That gives us a maximum. So here on this one, it goes from increasing to decreasing, which gives a maximum on this interval. So this is the correct one. Just looking at B again, we won't get a minimum. So this is not correct. We won't get a minimum on that interval. We'll get a maximum because it changes from increasing to decreasing. A minimum will occur when it changes from decreasing to increasing. So the reason for the minimum here is correct, but the interval, it doesn't happen here. it happens in the pi over 3 to 2 pi over 3. So let's have a look at the graph. This is the graph that we're just talking about. So we are going to get our maximum here at this particular point. We're going to get minimums here. We're going to get minimums here. We're going to get a maximum. So this maximum is a negative one. So the curve starts by going around to here. So at pi, when we're pointing in the direction of pi over 4, our distance is at its most negative in that direction. So that's this section here. This section, as it comes down, it comes around like this, and it comes back to 0. So these are our minimums on these two. Let me just switch over to GeoGebra for a second and have a look at how, so the minimums don't always have to occur when the Cartesian graph is in these particular points. It can occur when we change from negative to positive. If I just change this graph a little bit here, this one, which one are we doing? Yeah, we're doing this one. Minus sign. So what if we 2. So we're looking at this graph. We're going to get our minimums here and here. We're going to get our maximums here and here. As a polar graph, it's going to look like this. And as we rotate this around, we get our first maximum there. And then we get a minimum when we're pointing up here at 5 pi over 6. And then we're going to get another maximum over here. Now, we find the minimum here and here when it's 0 and the maximum's here and here. But if I change this to 3, the graph's going to look like this. It doesn't have a 0. So in this particular case, this will still be the maximum, but this becomes the minimum distance. This becomes the minimum. Let's see how that looks in terms of a polar graph. So if I change this to a 3, you see, we are going to get our minimum here at pi over 4. We are going to get our minimum here at pi over 4. And this is what a minimum looks like. But in terms of changing from increasing to decreasing and back, what we've got here is it's going to be decreasing here and then increasing here. So we go from decreasing to increasing. Always where the rate of change goes from decreasing to increasing, we will get a minimum. And from increasing to decreasing, we will get a maximum. So it looks like this. So we'll get our maximum. It's going to occur here. Is that 3 pi over 4? Get around to 3 pi over 4 there. We get our maximum distance. Okay, I'm just going to stop there with the video and I'll do another one, separate video for the next bit.